Hello, Chemistry 12. This is Mr. Chan. And today what I wanted to do was talk about a new topic. It's oxidation reduction reactions. Now, what is oxidation reduction reactions? Is a reaction that studies what happens is the giving or gaining of electrons. Now, this is very similar to acid bases, but acid bases involves the donation or the acceptance of protons or H+. Here, we're talking about the donation or acceptance of electrons. Now, in these types of reactions where electrons are transferred are called oxidation reduction reactions or redox reactions. And this is where electrons are transferred, okay? Now, some of you may have heard of that in biology, where if you add an oxygen, that's oxidizing, okay? But in biology, they simplify it a little bit, but what we're talking about is the transfer of electrons. Now, in redox reactions, there are two processes occurring simultaneously. These two reactions are called half reactions. So there are two types of half reactions that go on. One of them is called the oxidation half reaction. And in this case, this is where electrons are lost or produced. Both terms mean the same thing. It just depends on which book you use. And the resulting species gets more positive. Okay? Now, what do I mean by this? So if you take a look at the example here, aluminum going to aluminum plus 3 electrons, this would be considered an oxidation half reaction. Now, why? Because you take a look at the number of electrons, these are found in the products. Okay? And this is why we say it's lost or produced. Now, what do I mean by the resulting species gets more positive? What you do is you take a look at the charge. In this case, for aluminum, what you have is you have a charge of 0, neutral charge, while in this case, this aluminum has a charge of +3. Okay, so you notice what's happening to the charge. The charge is going from a 0 neutral charge to a +3. This would be considered oxidation. Now, for reduction, what happens is, in this particular case, what you have is a process for reduction where electrons are gained or used up as reactants, and the species gets more negative or less positive. Again, if I give you an example here, what you have is you might say, okay, take a look at the location of this electrons. Where is it found? Okay, now notice what happens here is here you have a charge of +2. And what you have here as a result is you have a charge of 0. Now, some of you might say, well, Mr. Chan, this looks familiar. Back in grade 11, didn't we talk about losing electrons and gaining electrons? Right. Now we call those oxidation or reduction reactions. Okay. Now, there is an acronym that some people use. It says LEO says GER. LEO is losing electrons. So if we have LEO here, so LEO, LEO would be losing electrons is oxidation. And you have gaining electrons is reduction. Okay, so what you have here is you have, if I highlight this, losing electrons oxidation, so Leo, gaining electrons reduction, so Leo GER. All right, now if we combine the oxidation half reaction and reduction half reaction, we get an overall redox. That's where we get the term redox from. What we have is we have our oxidation, the first two letters, and reduction. That's where we have redox reaction. Now, because the transferring of electrons is the main part of this reaction, we need to ensure that the number of electrons are balanced on both sides of the equation. Now, why do we need to make sure that the electrons are balanced? In this case, what you need to do is you need to follow the law of conservation of energy. Okay, I don't know if you was taught this in grade 10 or you learned it in physics, but in regards to the law of conservation of energy, energy cannot be lost or gained, can only be transformed. So in this particular case, with electrons, since electrons represent energy, what happens is the amount of electrons gained or lost in a redox reaction must be the same. So let's take, for example, the aluminum undergoing oxidation and the copper undergoing reduction. What happens is, notice in step number 2, what I need to do is I need to multiply. Notice I need to multiply the top equation by 2, the bottom equation by 3, is because I want to make sure that the electrons are now the same. Okay, so notice in step C that my electrons are the same, follows the law of conservation of energy. So now what I can do is I can cancel these two. And what I get is I get my overall equation. Now, you can test to see whether or not the equation is balanced by looking at the overall charge of all the reactants and overall charge of all the products. So in this case, if I took a look at all of this, this would be a total charge of +6. This would be also a total charge of +6. And so notice that these two are the same. So when they are the same, you know that they are balanced. Now, one thing for you to be aware of is you might say, well, Mr. Chan, what do you mean by copper 2+ and aluminum +3? Would be something like if we had, in this case, aluminum nitrate solution. Okay? And for the copper 2+ would be like copper nitrate. What happens is the nitrate ions are spectator ions. And so all we're worried about is the ions that have electrons gained or removed or are changed. Now, a couple of things for you to be aware of. Copper 2+ got electrons from aluminum, causing aluminum to be oxidized. So copper is called the oxidizing agent. Okay, so since copper 2+ caused aluminum to undergo oxidation, copper 2+ is the oxidizing agent. So it caused the oxidizing. It itself must be reduced. Okay, Aluminum gave its electrons to copper 2 plus, causing copper 2 plus to be reduced. So aluminum is called the reducing agent. So aluminum caused reduction, so therefore it is a reducing agent. It itself must be oxidized. Okay, think about that. See how those two words are related. So for example, a real estate agent helps you buy real estate. An insurance agent helps you buy insurance. Okay, so a reducing agent helps the other species to be reduced. All right, and we will be using those terms interchangeably later on in the future lessons. Okay, now let me give you an example here. So it says, let's take a look at question number 4D. Okay. It says, balance the following redox reactions, identify what has been reduced and what is the reducing agent. Okay. Now, so if we look at question number 4D, we have gold plus 3 plus cadmium gives you gold plus cadmium plus 2. Now, first of all, what we need to do is break it down into their major species, or what are the two reactions? Which one is the reduction? Which one is the oxidation? So what we have is we have Au plus 3 gives you Au, and we have Cd plus, oopsie, Cd gives you Cd plus 2. Now, in the top equation, we know that there are 3 electrons. Here, there are 2 electrons. How did we know the top one was 3 electrons? Because we needed to reduce the charge by 3 to go from 3 all the way down to 0. And here, cadmium lost 2 electrons because you needed to go from a 0 charge to a plus 2. So what we do here is, once we figure this out, the top equation we need to multiply by 2. The bottom equation we need to multiply by 3. Again, why do we do that? Is because we want to balance out the number of electrons. And then after we balance those out and we combine it, we have 2Au plus 3 and 2, oopsie, not 2, see, 3 and 2 CD will give you, oh, oopsie, no, wait a minute, I messed up here. That's okay. So we have 2Au, 3 CD, 2Au, and 3 CD plus 2. Okay. Now, that's how you would do it. You break it down into their individual half reactions, figure out how many electrons are either lost or gained, balance the electrons, and then put them back together. Now, what has been reduced would be the gold, because it went from a charge of plus 3 down to 0. And what is the reducing agent would be cadmium, because cadmium underwent oxidation, caused the reduction. All right, ladies and gentlemen, that is a brief introduction of oxidation reduction. All right, thank you very much. Have a good day. Bye-bye.